Hi everyone, welcome to Vedantu English. I'm Diksha Kaushal, your chemistry master teacher, and very good morning everyone. And yesterday we discussed about coordination chemistry questions, and today it is a turn of another high weightage chapter, that is electrochemistry. So do let me know everybody in the chat box if I am clearly visible and audible to you so that we can start with the session. Yes, students, very good morning. Chandu, Abhishek, Srinidhi, Ved, Snap. Yes. Tanushri, yes. Okay, let's start. Yes, start. Let's start. Yes, Yashwant, let's start with the session without wasting any time. So if you see this over here, right, total 12 questions we are going to do. So let's start with that. If you talk about the first question here, now all the important topics I have already covered. There will be some questions that will be quite twisted. So we are going to see every kind of question here, right? So let's see that first question is, you are given some reaction. The cell potential is found to be this. Now the potential of the cell is already given to you at 298 Kelvin. This is found to be this. The magnitude of standard electrode potential of this is going to be what? Now, guys, if you see, E cell is given to you. E cell is already given to you. They have given you E naught Ag positive, and they are asking you E naught, standard E naught of Cu2 positive to Cu, right? Now, what all you have to do here is apply the value of Nernst equation. What is Nernst equation? Let's see that. Right. Firstly, you should know this representation. First task is to understand the representation. So always remember, in the representation it is AC. That means the one that is on the left side is anode, and this will be cathode, and this is going to be cathode. That means at anode what is happening? At anode which reaction is taking place, and at cathode which reaction is taking place? Let's see that over here. At anode you have Cu2 positive. Now at anode there is oxidation, so it will increase in the oxidation state will be there. So this is Cu2 positive. That means loss of 2 electrons will take place. And in case of cathode, there is gain of 2 electron that is there. So here it is gain of 2 electrons, and hence it will become 2 Ag. So if you see this here, over here actually what is happening? There is gain of electron and it is becoming Ag. But the number of electron lost and gained should be same. So that is why we'll multiply this by 2. Now, we'll apply everything in the Nernst equation and solve the value of E naught cell from here, right? E cell is already given to you. You can write the value. This is E cell. Because why this is E cell? Why it is not E naught cell? Because they have not written it as standard electrode potential. They have written electrode potential. Cell potential is going to be this. That means E cell is given to you, and number of electrons lost and gained is going to be 2, right? So what you're going to do now, overall reaction you can write, these two will be cancelled. So overall reaction is Cu plus 2Ag give rise to Cu2 positive. This will be Ag positive, yes, plus 2 of Ag. That is going to be the overall reaction. Now, if you see the Nernst equation here, this I have written over here. Now, if you see the overall Nernst equation, that is E cell is equals to E naught cell minus 0.059 or 0.06, right? That you can write, divided by n log of oxidation by reduction or product by reactant, you can write there, right? So now if I write the formula here, E naught cell minus 0.06 divided by n factor log of QC. This is given to you 0.43. This is 2. This is log of Cu2 positive divided by Ag positive square. Because for pure solid, this one is equals to 1, and this one is equals to 1. For pure solid it is 1. So you will only take the ions here. So it is Cu2 positive divided by Eg positive raised to power square, right? And then put the concentrations here. Concentrations are also given. This is given to be 10 raised to power minus 2, and this is given to be 10 raised to power minus 3. Now put all the values over here and solve it, and you will get your answer. You will get the value of E naught cell here, that is given to be 0.46, right? Now once you know the value of E naught cell from here, from Nernst equation, you have calculated the value of E naught cell. Now what is exactly E naught cell? E naught cell is always equals to E naught of cathode minus E naught of anode, and here I am talking about the reduction potential. Now if you see this reaction here, what is cathode and what is anode? Cathode is Ag and anode is Cu. So what you can write here, this will be E naught of cathode is Ag. So in both the cases, this will be oxidation number will decrease because we are talking about oxidation. This is Ag minus E naught of Cu2 positive to Cu. Now the value of Ag positive to Ag is already given to you, that is 0.80, right? So this value is given to you, this value is given to you, put all the values here, right? This value is coming out to be 0.46, this value is 0.80 minus of E naught Cu2 positive to Cu, and that's how you calculate the value of Cu2 positive, right? Okay, right, everybody got it? So it was a question of Nernst equation. Now we are going to see varieties of question of Nernst equation, right? This was the simplest question of Nernst equation. Now let's move towards the next question on your screen. That is, it's a theory based question. So which of the following statement is correct? They are asking you, they have given you the reduction potentials. Ma'am, are reduction potential givens? Let's see. Oxidation number is decreasing, oxidation number is decreasing, oxidation number is decreasing. So definitely they have given you reduction potentials. But ma'am, how can we answer? Now remember one thing, whenever which one is reduced by which one, always remember for this case, if, just give me a second, in this case, remember, more the reduction potential, more is the power to get reduced, right? That means that thing will be at cathode, right? And lesser is the oxidizing power. More the reduction potential, more will be the oxidizing power. Because someone is getting reduced easily, then they can easily oxidize something. They have a very good oxidizing power. So if you see this here, in between Cu and Sn, which one will be a better, which one will get reduced easily? The one which has more positive value of reduction potential, that means Cu. So out of 10 and this, Cu will get reduced. Cu gets reduced. When you compare this with copper and tin, when you compare copper and hydrogen, then also Cu gets reduced, right? If you talk about hydrogen and tin, then hydrogen will get reduced. Hydrogen will get reduced if you talk about hydrogen and tin. Why? Because in case of hydrogen and tin, this has a larger value as compared to this. Now, copper 2 positive ion can be reduced by H2. Yes, with H2 also, copper 2 positive ions are getting reduced. That is correct. Then Cu can be oxidized by H positive. No, that is not correct. It will be reduced here. Then tin 2 positive ions can be reduced by H2. Tin 2 positive ion. No. Hydrogen is reduced when you have tin in this. So this is also not correct. Tin can be oxidized by, wait a minute, tin can be oxidized by, they are asking the correct statement here, right? tin can be oxidized by Cu2 positive ion. If you have Cu2 positive ion, tin will be oxidized. Yes, definitely. If Cu2 positive ions are getting reduced by H2, then when you compare copper and tin, copper 2 positive is getting reduced, then tin will be getting oxidized. So this is also correct. So answer will be A and D are the correct options here, right? Okay, A and D are the correct options here according to this question. Next question is based on Nernst equation itself. A cell diagram contains 1 liter of buffer solution. Now this one is interesting because here ionic equilibrium is related to this electrochemistry. It's not a difficult question, but it's just two things are related with each other. So you need to like just put the formula and get the value of H positive value here. So see, a cell diagram shows contain 1 liter of buffer solution of HA. pKa value is given to you in both the compartments. Okay, here also H2 you have, here also H2 you have. Concentration of H2 and Na is given to you. Pressure is also given to you, right? Now one by one we'll see, right, that what is there. If you see this value here, the cylinder contains 1 liter of a solution of this, and in both compartment, what is the EMF of the cell? Okay, so they have given you two same compartment. This is SHE, this is SHE, right? And they are asking you what is EMF of this particular cell. If I say this will be your anode side, this will be cathode side, this will be cathode side. Okay, so firstly one by one on anode and cathode side we'll see what we have to do. On anode side, what is happening? On anode side, it is the oxidation number, if you see, it is losing, right? On anode side, what is happening? Oxidation number should increase. It is losing the electron, so H2 is getting converted to H positive here. That is happening at anode side. That means on the left side this is happening. And on the left side they have given the value of pKa to be 4. If you talk about, this is the formula of buffer solution, pH is equals to pK plus log of ionized form by unionized form. This is from ionic equilibrium, right? So this is A negative, ionized form is given to be 1, unionized form is given to be 0.1. If you see this here, this Na, A negative, that is the ionized form. In the salt, it is given to be 1 here. And here it is given to be 0.1 here. So what you will do, you will just put the value. This is 1, this is 0.1, this is given to be 4. You will solve this and you will get the value of pH to be 5. If pH is 5, H positive is going to be 10 raised to power minus 5. Okay, so we know that this concentration here is 10 raised to power minus 5, which is the anode reaction. Now similarly on the cathode side, I think they have not mentioned here, but on the cathode side the pKa value is given to be 5. Okay, this is given to be 5 here. Now on the cathode side, this is the reaction at cathode. At cathode, what will happen? There will be gain of electron, right? So H positive will be converted to H2 here. It will gain 2 electrons and will be converted to this one. Again, what is the value of pH? pKa plus log of A negative by HA. Now, if you see this here, here the value of A negative is 1 and value of HA is going to be 0.1, right? That is already given to you, right? Yes. So just put the value. Wait a minute. Is it given to be? No, this is not actually point. This is aqueous and this is 1 molar. Okay. So both the values are given to be 1 here, right? So you will just put this here in this particular question solution. pK is given to be 4 here plus log of A negative. Is it given to be 4 throughout the solution? Let me see. Is it given to be 4 throughout the solution? The cell diagram shows contain 1 liter of buffer. Okay, throughout the solution only it is given to be 4 itself, right? So we'll take it as 4 only. I thought it is given to be 5 here, right? Here also it is, because it's a buffer solution. This is given to be 4 here. This is 1, this is 1. When you solve this, your answer of pH is going to be 4. Hence H positive concentration is going to be this. Now here this is the cathodic half cell. Now you will add these two reactions here. If you see, anodic was H2, give rise to 2H positive plus 2 electrons. When you add this will get consumed. This will be 2H positive with concentration 10 raised to power minus 4. This H2 and H2 will be cancelled. Then this will give rise to 2H positive with 10 raised to power minus 5 concentration. Now they are asking you the value of EMF, right? Now because both are SHE, that is why E naught cell is automatically going to be 0. So you can write this over here that E naught cell is going to be 0. And what you have here, E cell is equals to E naught cell minus 0.06 divided by N log of QC. Now here this is given to be 0. Log of QC. What is the value of QC here? If you see this question here, the value of QC is going to be H positive concentration square divided by H positive concentration square. Now this is 1, this is 2. Here this H positive concentration of product side is 10 raised to power minus 5 and this is 10 raised to power minus 4. Right? Now what you will do? You will just put the value of QC. N factor, if you see, N factor is going to be 2, number of electron lost or gained is 2 here. You will put all the values here and you will get your answer. E naught cell is 0 here, N factor is 2 and this is QC, that is 10 raised to power minus 5 square by 10 raised to power minus 4 square. You will put the value of QC here and solve this, you will get your answer. Tell me, is that clear? Right? Yes, yes, both are SHE. Array, see, nothing is there. Usually what happens, they give you H positive concentration. Now what trick they have used, they have not given you H positive concentration. So if you see this formula, this is not from electrochemistry. This is a mixed question of 2 chapters. This formula is buffer solution formula, where pH is equals to pK plus log of A negative by HA. Right? Now pK is given to you in the question, and for both the compartment, this is anodic, this is cathodic, they have given you the concentration. HA concentration is 0.1, A negative concentration is 1. Here both the concentrations are 1, and accordingly I have solved the value of H positive in both the cases. Now just simply I know that at anode what will happen, there will be loss of electrons, at cathode there will be gain of electrons. Now when I add these two equations, H2 will be cancelled, electrons will be cancelled, you will have this as the overall equation. Then you solve the value of QC here, N factor is 2 here, E naught cell, when both are SHE, then E naught cell is automatically going to be 0. Tell me guys if that is clear. It was an easy question. It was not a difficult question, but 2 concepts, right, there were. If you don't know ionic equilibrium, then obviously you are going to find this difficult, right? Okay. Yes, everybody, tell me. Okay, understood. Shall I move ahead? If it is clear, then hit the like button. If it is clear, right? Yes. So many students are watching, but you are not liking the video. That's very sad. Right? If it is clear, then write yes. It is a beta question. Yes. So let's see next one. Standard electrode potential of 2 half cells are given to you. If Fe2 positive, Fe3 positive, these are kept together, the concentration of which one will increase? See, firstly, you have to see which one will behave as a cathode, which one will behave as an anode. So the one with higher value of electrode potential will behave as a cathode. So this will be your cathode and this is going to be anode. What is the value of E naught cell? This is E naught of cathode. Cathode is Fe3 positive to Fe. oxidation number is decreasing, minus E naught of anode, that is Fe. Here oxidation number is should be increasing, but we are writing reduction potentials. Now put the values here. This is given to be 0.77. This is given to be minus of minus 0.44. You don't even need to solve it. Just see the value here will be positive. Whenever E cell value is positive, now there is a relation, that is delta G is equals to minus NF E naught cell. So if we say this is positive, then automatically delta G will be negative, which accounts for spontaneous process that we have studied in thermodynamics, that whenever a reaction is delta G is negative, it's a spontaneous process. Spontaneous means this reaction will take place in the forward direction. And if you combine this particular thing here, it is going to be at a node, actually what takes place at a node, Fe is getting converted to Fe2 positive. So here what will happen, you will have this is Fe3 positive, this is Fe2 positive. Here Fe is getting converted to Fe2 positive, and here if I add all these equations, this is Fe3 positive, wait a minute, Fe plus Fe3 positive, right? At cathode there is reduction, no, right? So this is Fe2 positive. Standard electrode potential of two electrodes are given, wait a minute. At a node there will be loss of electrons. Loss of electron means Fe to Fe2 positive. This is going to be gain of electron, means Fe3 positive to Fe2 positive. So this will be Fe3 positive, Fe2 of Fe2 positive, right? Wait a minute. So if you see this, if it is moving in the forward direction, the reaction is spontaneous, so it is moving in the forward direction. So what will happen? First thing is Fe will decrease, Fe3 positive will decrease, and Fe2 positive will increase, because it is in the forward direction. So we can say Fe3 positive increases, that is not correct. Fe3 positive is decreasing, that is the correct. Mass of Fe increases, no, Fe also decreases. Concentration of Fe2 positive decreases, no, Fe2 positive will increase. So answer will be B is the correct answer here, right? Okay, yes, you are in the right track, ma'am, go ahead. Thank you, right? So let's see this question now. Next one is this one. Again, this one is also, it may seem complex to you, but actually it is not complex question, okay? So I especially picked up some questions for you which will open up your brain. It's not usual random questions, but it is something specific in that questions, okay? So if you see this here, here also two answers are correct, right? Consider the cell that is given to you, the cell reaction will be spontaneous. If now guys tell me, spontaneous means delta G should be negative and E should be positive, right? E of cell should be positive. So firstly what I'll do, I'll just write the equations here. If you see, this is given to be, this is the anode side and this is the cathode side. So at anode, firstly I'll write, at anode what you have, H2 is getting converted to H positive, it is losing 2 electrons, right? And at cathode what is happening, at cathode what is happening, okay, I'll just write the value at cathode over here. At cathode what is happening, at cathode you have H positive, right, is getting converted, it is gaining 2 electron and it is getting converted to H2. Now I'll just add these two equations. When you add these two equations, or you know, you can just write this over here only. At cathode what is happening, At cathode, as you can see, H positive is getting converted to H2 by gaining the electrons. So we'll balance this as well. Now, when you make the overall equation is going to be what? Tell me. Overall equation is going to be, this will be cancelled. Oh, this will be cancelled. Now, ma'am, H2, H2, why it is not cancelling? Because its concentration is different. Here H2 is X, here it is pressure P1, here it is concentration X1, here it is X2, and here it is P2. Okay. So what I'll do, I'll make the overall reaction, that is H2 plus 2H positive give rise to, this is going to be 2H positive plus H2. Now let's write down the equations here. H2, here it is P1, and here it is X1 concentration. Here it is no, on the product side it should be X1, right? On the reactant side it is X2 only, because on the reactant side you have this and this, so it will be P1 and X2. Product side it is X1, so you'll write here X1, and this is P2. Okay, this is the overall reaction that you have, right? Now if you see this over here, wait a minute. Now if you see this over here, I'll just explain you here. When you write down the value of E cell, because here both are SHE, so E naught cell is automatically going to be 0. E naught cell is 0 here. So this is E naught cell minus 0.06 divided by n factor log of QC, right? This is given to be 0. This is E cell, so it will become minus 0.06 divided by 2 log of QC. QC is what? QC is what? Tell me. QC is equals to product. Product is H positive. This is H positive square. This is X1. So I'll just write it here. X1 square. This is X2 square. So it is X2 square, right? This is P2. Pressure here is P2. Here pressure is P1. So this is the value of QC. Product by reactant raised to power the stoichiometry, right? So you can just write it here, X1 square by X2 square, X1 square, or you can just write down X1 by X2 whole square, and this is P2 by P1. Now see, this is the equation. Now if you have to make E cell positive, if you want to make E cell positive, then this whole value has to be negative. Then log of X1 by X2 whole square P2 by P1 has to be negative. So two cases we have. First case we are taking, let's say P1 is equals to P2, because first is P1 is equals to P2, then which one will be correct? X1 greater or X2 greater? So I'll take two cases here. If P1 is equals to P2, P1 equals to P2, right? If pressure of this is equals to this, then it will be log of X1 by X2 whole square should be negative. If I want to make log of anything negative, that anything has to be less than 1. Okay, you can also write this as 2 of log, because when you take this here, this will come in front, so it will become 2 of log X1 by X2 should be negative. That means X1 by X2 has to be less than 1. So it will be X2 will be greater than X1. Okay. So you can see this over here. X2 is greater. So B is the correct answer. Now that means this is definitely not correct. When I put X1 and X2 equal, then what will be the answer? If I put X1 and X2 equal here, if I put X1 is equals to X2 here, then which thing will be there? Then log of, if I put X1, X2 equal, then log of P2 by P1 should be negative, right? That is the only option I am left with. So log of anything is negative. That means this anything P2 by P1 has to be less than 1. That means P2 is less than P1. So P1 is greater here, right? So you can write this here. P1 is greater, that means C is the correct option here. So two options are correct here. B is the correct condition and C is the correct condition, right? So answer is B and C are the correct answers here. Okay, thank you. Done. Okay, everybody. Now let's move ahead. Now let's move ahead with the next question. That is the standard Gibbs free enthalpy. They have given the standard Gibbs free enthalpy for the given reaction in kilojoule is given to be this, right? Now they are asking you delta G. So what is delta G? Delta G is equals to minus NF E naught cell, right? E naught cell is given to you. N factor is 2 here. E naught cell is given to be 2. Faraday is going to be 96500. Put all the values here and you will get your answer. NF 96500 or 9600, it's totally your choice, right? But I take it as 96500. Let me see if it is given. It is already given to be 96,000. So what is given in the question, we will take that, right? So instead of taking this, what we will take what is given in the question, right? And this is 2 volts. Solve this value. This will be in joule per mole, right? After that, converted into kilojoule, and you will get your answer here, right? Next, guys, we have in an electrochemical cell of lead at standard temperature. Now, this is also very important question. This all are important questions here, right? So, in this case, what we should remember is that Gibbs free enthalpy is conserved, E cell is not conserved. So what we have to see, we have three things here. First is PB. So let me just see. Yes, we have an extra page there. So I'll just firstly draw. This is PB to PB2 positive. So I'll just draw this here. Firstly, we have PB4 positive to 2 positive, then PB. So I'll just draw this here. This is PB4 positive, then to PB2 positive, then it is to PB. So always write it in this manner that it is getting reduced. Now they have given you PB4 positive to this. You have to write the this is oxidation potential, but I'll calculate the reduction potential firstly. Just focus on reduction potential. Oxidation potential is opposite of that. So this is given to be, this is what we have to calculate. Take it as E. Number of electron here will be 2. How many electrons are involved? Mark it in this circle, that is 2. Right? Then for PB2 positive to PB, here it is given to be M. Here electrode potential is M and electrons involved are 2. Then if you talk about 4 positive to PB, it is given to be N. 4 positive to PB, it is given to be N. Electrode potential is N and electrons involved are 4. Now all you have to do is apply the Gibbs conservation of Gibbs free enthalpy. Delta G3 is equals to delta G1 plus delta G2. Delta G is nothing but minus N1F E1. For 3 it is N. For 3 it is N, right? Or you can just write this is E3. This is minus N1. This should be N3. Right, this should be N1, this is F, this is E1, this is minus N2, F, E2. So you can just cancel Faraday, Faraday, Faraday and negative. This will be N3, E3 is equals to N1, E1 plus N2, E2. Then just solve this value here. That is going to be, what is N3? In 3, this is 3. This is 1, this is 2, this is 3. That is the case, okay? By adding these two, you will get this. So it is 4 into N is equals to, N1 is this E, this is 2E plus 2M. So 2E equals to 4N minus 2M. So E is equals to divided by 2. So we will say E is equals to 2N minus M. This is the reduction potential. To calculate the oxidation potential, it will be M minus 2N. And that is going to be the answer, M minus 2N. So you compare this M minus 2N. So X is going to be 2 here. Right, everybody? Tell me. Yes. Now let us move to the next question here. This way also you can solve it by making the chart. It will become easy for you to understand. Then next question is this one. See how do you answer this? Now, Nernst equation questions we have done, right? So they can ask you equilibrium and delta G naught and all these questions they can ask you. That also you should remember. But now let's move ahead with the conductance, conductivity. What kind of questions are there? So conductivity of 0.1 molar solution of weak monoprotic acid. They have given you for weak monoprotic acid, the conductivity is given to be this. What is conductivity? That is kappa. Limiting molar conductivity of it is this. Limiting molar conductivity, that means this is given to be 400. This is kappa. And if the dissociation constant of acid is this, what is the value of y? Alpha, Ka you have to solve here. What is the value of Ka? Ka is equals to C alpha square, right? Concentration is given to you, concentration is given to be 0.1, right? Alpha value you will calculate by molar conductivity at concentration C divided by infinite dilution. That means infinite dilution, this is also given, this is also given. So to calculate alpha, you have to solve the value of this thing, right? So to solve this value, what you have to do, you should know that if things are given here in centimeter, 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 then what we will do, we'll just do kappa multiplied by 1000 by concentration, right? Kappa is given to you, that is 2.19 into 10 raised per minus 4, right? Concentration is given to you, this is kappa, this is concentration, right? You'll put this value, you will calculate the value of molar conductivity at concentration C, put it here, you will get the value of alpha, put it here, you will get the value of Ka, right? Okay, so calculation you have to do yourself, I'll just explain you, right? So this is the value of molar conductivity at concentration C. Put all these values, then alpha value, this is molar conductivity at C, this is infinite dilution, that is given to you 400. Over here it is given to be 400, right? Then you solve this, and this, students, right, usually we see monoprotic acid, usually we ignore the value of alpha, but as alpha here is coming out to be 10 raised per minus 3, so it is not that small, right? So you will use Ka value here equals to Ka value here is equals to C alpha square by 1 minus alpha. Okay, solve this and then compare it with the answer, you will get the value of y here, right, everyone? Next question is based on the similar thing. Molar conductivity of aqueous solution of Ha is 200 and this is in Simon centimeter square only. pH of the solution is 4, calculate the value of pKa, right? Can you see, first question was quite simple on the like direct formula based question it was, but here something pH is given, calculate the value of pK, what exactly they are trying to do, let's understand that, right? So pH is given, pK is given, let's see what we are going to do here. Firstly we'll calculate the value of this is molar conductivity at infinite dilution. For Ha it is nothing but HCl. So what all the molar conductivities you have, HCl, NaCl and Na. So you want to calculate the value of Ha from here. How do you do that? Ha will be, you have to have H also, that means HCl, A also, that means Na. And you will subtract NaCl from here, so that in the end you are left with only H positive and A negative, that accounts for Ha. So you will add the infinite molar conductivity of HCl and Na, then subtract NaCl from there, you will have the infinite molar conductivity here. pH is given, that means H positive concentration is given, that is 10, if pH is 4, H positive concentration is 10 raised per minus 4, right? And H positive concentration in Ha, if you see, that is nothing but this is H positive, A negative, right? If you see, this is the initial concentration 0, 0. This will become C minus C alpha. This is C alpha. This is C alpha. So H positive concentration is nothing but it is C alpha, right? So just remember that H positive concentration, that means C alpha is given to be 10 raised to power minus 4. Just remember this thing that C alpha is 10 raised to power minus 4. Now alpha is nothing but concentration C molar conductivity and infinite dilution molar conductivity. Infinite dilution you have calculated here, and for concentration C it is given. This is molar conductivity at concentration C is given. Infinite dilution you have calculated. Now alpha you know. Alpha value you will put here, you will get the value of C, that is concentration here, right? Okay, alpha value you know, or you can just directly solve this. Ka is nothing but C alpha square. You can write it as C alpha into alpha 1 minus alpha. Alpha is 0.5, 0.5. C alpha is 10 raised to power minus 4. Put all the values here and you will get the value of Ka. Ka is 10 raised to power minus 4. Take the log here. Then Pk, what is Pk guys? Pk is equals to minus log of Pk. Ka. Ka is given to be 10 raised to power minus 4. This is minus log 10 raised to power minus 4. Minus will come in front. So minus of minus 4. Log of 10 is nothing but 1. So it will be 4 is the correct answer here. Right, so you will see in electrochemistry if they want to make a question like not difficult, this is also not difficult, but it's just that use of ionic equilibrium is there, right? Okay, right everybody. Now let's see the next question here. That is, let's see the next question everybody. Let's see. Yes, beta only, ma'am. If now this one is an interesting one, right? This one you might do mistake. If you have never done this question, you might end up doing mistakes here. So if 100 milliliter solution of 0.1 molar HBr is titrated using a very concentrated solution of NaOH, HBr is reacted with NaOH to give NaBr plus H2. Then the conductivity of the solution at equivalence point will be what? Conductivity, and report conductivity at equivalence point, specific conductance, that is K they are asking you. You have to calculate the value of kappa and report your answer by multiplying with 10, that we will see. But remember that answer should be in Simon per centimeter. Assume a very little variation of molar conductance of NaBr given the concentration at infinite dilution is this. See, if you talk about in case of HBr, if you calculate the what is the molarity of HBr, that is 0.1. See, if they are saying that there is very little variation, right? Either you can firstly calculate the number of moles, but you know that number of moles of HBr and NaBr are same. If volume is also same, that means molarity after this reaction is also going to be same. So here we can say after this reaction, NaBr concentration is also going to be 0.1. So concentration, molarity, concentration of NaBr is going to be 1. That is the important point 1. That is one important point, that if you see this reaction, 1 HBr is giving you 1 NaBr, right? And they are saying very little variation is there. So that is the reason if this is 0.1, this is also going to be 0.1. Now, if you see at infinite dilution, it is given to you. So what we will do here, at infinite dilution, Na plus Br is given. So you can calculate the molar conductivity at infinite dilution of NaBr by adding the molar conductivity of Na positive plus molar conductivity of Br. Right? This you have calculated. Now, what they are asking you, concentration is given, infinite dilution molar conductivity is given. you have to calculate the value of kappa, so we'll calculate it from here only. This though is not important. Let's see this, right? NaBr, that you have calculated the molar conductivity. Now remember one thing, if you see, the molar conductivity is equals to kappa by concentration, right? That means, now why ma'am you have not multiplied it by 1000? Because here things are in meter, things are in meter, not centimeter. That's why I have not multiplied it by 1000. So it will be this conductivity, right? Molar conductivity is equals to kappa by C. So here what you will see, molar conductivity, you know the value, you have calculated it. Concentration is nothing but zero point 0.1, right? Now remember that here concentration is in, remember one thing, this concentration is in zero point 0.1 molar. What is molar? 0.1 mole per liter. Liter means decimeter cube. 0.1 mole per decimeter cube. And you have to convert it into meter because everything is in meter. So that's why it will be multiplied by 1000 and it will become 100 mole. This is per meter cube. Okay, that you must remember, that here we are calculating this in meter, not decimeter. That's why unit conversion here, why this question is so important, because here the problem is the unit conversion only. That is the problem. First thing is, this is given in meters, so the formula will not be multiplied by 1000. And here when you put the value of concentration, you will put the value as 100, not 0.1, because 0.1 is in mole per liter, mole per decimeter cube. We have to define it in mole per meter cube, right? So put the value of this here, calculate the value of kappa, that is given to be 1.2. Then they are saying that multiply this value that you are getting into 10, then the answer will be your correct answer, that is 12 is the correct answer here. Because they are saying that assume, they are saying report your answer after multiplying it with 10. So after multiplying it with 10, we'll get the answer as B is the correct answer. Okay, yes everybody, which is C. If this is 0.1, this is also going to be 0.1, but this is in mole per liter, so I have calculated this in mole per meter cube. It is coming out to be 100 by multiplying it by 1000. Now infinite dilution molar conductivity also hints are given to you, you can calculate that, right? And we know that because they are saying that assume a very little variation of molar conductance between given concentration at infinite dilution. That means, especially they are saying that molar conductivity at C is equals to molar conductivity at infinite dilution. So that's why here I have taken infinite dilution molar conductivity is equals to kappa by C. Why it is not multiplied by 1000? Because things are in meters. So 1000 we will not multiply here. Right? Okay. Yes. Now let's see the next question here, that is, what is the volume of oxygen liberated at anode at STP in the electrolysis of aqueous CuSO4 when current of 2A is passed for 8 minutes? Now for this you should remember Faraday's first law, which is again a very important thing, right? So here weight is equals to ZIT. What is Z? That is molar mass by N factor into Faraday, IT. Now, if you see volume, you know what I'll do? I'll calculate the number of moles. Number of moles is an easy way. So if you see weight by molar mass, that is nothing but, this is N factor into Faraday. This is number of moles is equals to IT by N factor into Faraday. This is the formula of first law of thermodynamics, or first law of thermodynamics I am saying. This is the formula of first law of Faraday. And here this formula, this Z is electrochemical equivalent, which is nothing but molar mass by N factor into Faraday. Now if you see, this is the volume of oxygen liberated at anode, in the electrolysis of aqueous CuSO4, right? So if you talk about electrolysis of aqueous CuSO4, firstly guys, you need to tell me here what will be the reaction, what will be the N factor here. What will be the N factor here? Right? Okay. So if you see this here, N factor you have to calculate, current is given to you, that is 2, and time is given to you, that is T, and Faraday is nothing but Faraday is 96500. So once you calculate the number of moles here, number of moles are also volume divided by 22.4, so you can easily calculate the volume as well, right? So let's see. First thing is, this is the reaction that they have given you, right? When it is being converted to O2 from water in electrolysis, right? Now you might think that, ma'am, why it is electrolysis of aqueous solution, ma'am, why we have used at anode, ma'am, why we have used this? Because see, at anode either SO4 2 negative can get oxidized. See, what are the, this you must know from product of electrolysis, that what is the reaction you will use. Cations are what? Cation is either water will be converted to H2, or you will have Cu2 positive getting converted to Cu. And at anode there will be anion. At anode there will be anion. This is at cathode, there will be cation, right? At anode either water will be converted to O2, or SO4 2 negative will be converted to S2OH 2 negative. Now see, here what will be used? Here copper will be chosen because it is 0.34, it is positive, it is more than this. And in this case, what will we choose? This will be chosen because this is more. In this case, this is more, that is water will be chosen. Water will convert to O2, right? So now if you see this here, that means at anode H2 is getting converted to O2 from this reaction. H2 is getting converted to O2 by giving 2 electrons. That means N factor is equals to 2. Now this reaction from electrochemistry you must know as it is, that how water behaves in as a cathode and how it behaves as a anode, right? Now if you see this I and T is given, now time we will put in seconds. Time we will put in seconds. Okay, minutes, 8 minutes were given, we are putting it in seconds. Current was 2. N factor here, if you see, wait a minute, N factor here for O2, okay, 1 molecule of O2 you have, no? So if you talk about, they here they have asked you at a node the volume of this, okay. So here if you see, for half of O2 it is 2 electrons. For 1 mole of O2 liberated, it is going to be 4 electrons, right? So N factor will be 4 here. You put all the values, you will get the number of moles of O2. That is going to be this thing. So number of moles of O2 we have. Once we have the number of moles of O2, we know that number of moles is equals to volume by 22.4. So volume you will calculate, number of moles multiplied by 22.4, you will get your answer of volume here. Okay, yes, that is your first law of Faraday. Then last question is, which one of the following statement is correct for electrolysis of brine solution? Brine solution is NaCl and it is water. So in case of cathode, you will have cation, that is Na, and you will have water getting converted to H2. At anode, you will have Cl negative and you will have water getting converted to O2, right? So what is the actual thing that you will have, right? Let's see it in the form, it in the full-fledged reaction. So at cathode, which thing will be chosen? H2O getting converted to H2. At anode, Cl getting converted to Cl2 will be chosen, right? This is according to the selection process. At anode, that thing will be selected which has high reduction potential. High reduction potential, and here that thing will be selected which has high oxidation potential. Okay, so according to that you have chosen here water getting converted to H2, here Cl getting converted to Cl2. So if you see this here, O2 is not formed, H2 is formed at anode, definitely not. Cl2 is formed at cathode, definitely not. Cl2 is formed at anode. Here Cl is 2, here this is 2. So at cathode H2 is formed, at anode Cl2. But definitely in this reaction, OH negative is formed at cathode, if you see, right? Because of this reaction, OH negative is formed at cathode. Okay, yes, got it. So this is your homework question, everybody. See this. The amount of an ion liberated on an electrode during electrolysis does not depend upon which of the following: conductance, current strength, time, electrochemical equivalent of the weight. Okay, right, everybody? Yes, definitely IIT Delhi, right? Yes. So that's it for today, guys. Now I'll take your leave and all the best for today. It's 7 and already we have completed all the questions. But before going, let me just remind you that over here, if you see, first you hit the like button over here, right, on this video, right? Because see, in the morning 6 a.m. we are waking up and teaching you, right? And also one more thing, if you see in the description box of this video also, it will be added here. So if you see this over here, here in the description box, there will be Eclavir rank booster test series. So click on there, and Eclavir rank booster test series is right now just provided at just 999. It is just for few days. This offer is 80% off. So it is at 999. So you can just buy now the option. You can just click it and buy now. Acha, what you will get here? You will get 93 high weightage topic wise test, and you will get, wait a minute, here it is written, 11 part test and 25 full syllabus test. Those topic wise tests are extra, and this is extra, 11 part test and 25 full test. So you can say 25 plus 11 plus 93, all these tests you will get here, right? And here this parts test and full test will be around 3 hour full-fledged, like a paper. You will have 75 questions will be there, just like your JEE Mains, right? Okay, yes. Okay then, guys, that's it for today. Now let me know in the comment section what is your answer for this particular question. Till then, bye bye, take care, all the best for the day. Make this day highly productive, because you have started with something very, you have started already with a good productivity. So make this day worth it. Till then, bye bye.